Let's do another set of problems involving the ratio and root tests. I have negative 5n over 2n plus 1 to the 3n. So since I have something raised to the nth power, this seems like a pretty good candidate for the root test. I wouldn't recommend doing this with a ratio test. I think it'd actually be kind of nasty. So I would say it's a bad idea. So again, if you have something just raised to an nth power, generally speaking, that's a root test. If it's got factorials or something, I would go ratio. So I have a sub n negative 5n over 2n plus 1 to the 3n. So the absolute value of that is actually this. So then what we're trying to do is we're trying to take the nth root. So I need the limit as n goes to infinity of the nth root of this thing. Negative 5n, 2n plus 1 to the 3n. Now, we want to write the nth root as a power function instead. So we're going to write that as to the 1 over n. The reason we want to do this is we can use the properties of exponents to say, well, that's the limit as n goes to infinity of negative 5n, 2n plus 1 to the 3n times 1 over n. So clearly those are going to have cancellation here, getting us the limit as n goes to infinity, negative 5n over 2n plus 1 cubed. So we could then distribute the cubed if we wanted to. I'm going to go ahead and do that. What we would get is the limit as n goes to infinity. I'm also going to apply the absolute value here just to make things simpler. We're going to end up with 125n cubed over 2n plus 1 cubed. Now 2n plus 1 cubed, I'd have to think about that. I don't remember my cubics very well. I would bet that's 8n cubed plus 6n squared, or 12n squared plus 4n, or 6. I bet that's a 6. It's been a while since I've kind of distributed out my cubes, old Pascal's triangle and all that. I think that's right. If it's not going to really matter, I promise. When we take the limit as n goes to infinity here, we're going to end up with 125 over 8. And so this number here is larger than 1. Since it's larger than 1, it's guaranteed to be divergent. So since it's divergent, the reason why I say this isn't going to matter much is I know that the leading term was going to be 8n cubed, and that's what's going to determine this limit here. So I apologize if some of these are incorrect, but they ultimately don't matter for what we're trying to do here. Again, remember, ratio and root test both. If this limit comes out greater than 1, no dice. So finally we have n divided by a natural log of n to the n. So in this particular case, we could try for a ratio test. We could. I would not recommend it, but we could do it. If we really, really, really wanted to, I'm sure we could try. Let's not do that. Let's just do a root test. But we do need a preliminary. There's something that we haven't really talked about yet, and it's the idea of what is that? That's a good question. So the short version is that it's 1. And the long version, if you want to know, I'll do it. And if you don't like this, just scroll through till I get to this part. But it comes down to the fact that you have to do that sort of log limit thing where you actually say, all right, this is n goes to infinity of n to the 1 over n equals y. We just sort of assume some sort of y. So we take the log of both sides. And then we can bring that power down. So that becomes 1 over n in the front. But we don't want a 1 over n in the front, so we actually do this. So we have natural log of n over n. If you take that limit to infinity, you're going to get an infinity over infinity. Take L'Hopital's rule, you're going to get a 1 over n. That limit drops down to 0, so we get that 0 is natural log y. So y must equal 1, which is where we're at here. That's just kind of, that's the way that that limit is performed. Why do I say that? Well, we're going to use that here. So a sub n is that. Now, we have n equals 2. So I guess technically we do... No, actually we're good, because for every n past that, even when n equals 2, it squares, so it becomes positive. So we can actually remove the absolute value here. We didn't have to, but why write it if you don't have to? So this is your a sub n, so we need to take the limit as n goes to infinity of the nth root in natural log of n to the n. So by the properties of roots, we can split it on top and bottom. So this clearly has a cancellation property. It's the nth root of the nth power. So I have the limit as n goes to infinity. At which point I can then use the properties of limits. It says this is the limit of the top divided by the limit of the bottom. Well, limit of the top is 1. Limit of the bottom is infinity. We get 0. So since this is 0, we know that this is going to be an absolutely convergent series. And that's really the ratio and root tests. They're really not hard, but the key is recognizing when to use them. What's the, what's sort of the order of operations of how to use tests, and ultimately practice.